Thank you, Aaron. Is this working? Cool. Welcome, everyone, to my talk. My name is Mike Edwards, and I'm going to be talking about headless rendering 101. So it's not 101 ways to render, but this is sort of an overview of my exploration and journey into going headless, making that transition from being a Sitecore and MVC developer to I won't say full stack, but because I really don't like that term, but yeah, a full stackish developer. So, who am I? I'm a Sitecore MVP, 9-time MVP. I work for Conibos. I've worked on the Glass Mapper project that some people have used. I've also worked on tools like team development for Sitecore, Razzle, and I've been in the Sitecore community for about 17 years. So, hanging around this space for some time now. Cool. So, I'm going to start with the journey that we've been kind of on in terms of our development, especially when it comes to rendering websites. So, who started with web forms? Let's see, hands up, who started web forms? Cool, so that's all the old people. That's like, who started with MVC? Cool, all the younger people here. And then, who are the really young ones who probably should still be in school and just doing React right now and things like that? Yeah, the kids. The kids. You know, we started off with these back in the day, and we had things like request lifecycles, and everything was on the server. And it was kind of good, you know. It was kind of easy, I would think. You know, we knew where everything was. Web forms was a bit fun because you had the weird binding models and view state. But it was, overall, quite a nice environment to work with. The only one thing we had a challenge was obviously speed. You know, people wanted to do things quicker. And the one thing that made that whole thing easier was we just bought a CDN in. You know, we didn't really have to change our development practices. That made it super simple. We just bought an Akamai service or something like that. CloudFront came along. It was great. So we could all think our job was done at this point. You know, the web didn't need to change. We were rendering data. We could just sit down and drink coffee all day. But then people said they wanted to do more. People started to show that we could do things with JavaScript in the browser. You know, and this is like when JavaScript started to make its emergence from not just being like a funny tool to make rounded borders on images and things like that into actually something that was full-fledged. Was it a good idea? Not sure. You know. Back then, I don't know, trying to do JavaScript in IE, Firefox, and all the different browsers, there was no commonality between them. It was a frustrating experience, but people pushed through. Things like jQuery came along. Who's used jQuery? Cool. Who misses jQuery? Yeah. I'm going to put my hand up for that. I like jQuery. It was simple. But you know, the JavaScript community kept pushing and pushing more and more on what they could do within the browser. This led to this problem, you know. Suddenly we're chucking everything in our website. You know, we're packing everything possible into it. Massive file downloads, trying to get, you know, all these features into the front-end client, bloated downloads. And then we had the whole problem of, like, how do we minify it? How do we strip these things out? How do we pull back so that when somebody loads a site on their mobile, it's not going to take about a week and a half to download, especially on those lower-powered ones. So we then entered a new world. This is where our two React kiddies start to come in, I think. So we bring in these new challenges. E. And that means getting rid of asset, not MVC. To a certain extent, we still have it around, but you know, we need to start replacing this. You know, the new paradigm now is that the client is going to do a little bit more than that. We're going to try and move away from the sort of standard controller CSHTML rendering mechanisms. And that brings in a load more options of what you want to do, of how you can render a page. So what I want to explore is, like, if we get rid of the MVC, if we get rid of the web forms, I was actually looking at a Sitecore site the other day that still uses web forms, even 15 years later. It should be retired. And so we're going to look at the options. Now, you can see we have a lot of options. Spas, SSR. You know, who's heard of island architecture? Any new terms? That's good. You're the right audience. And if you've heard of all of these, then there's no point in me coming to this talk. So what I'm going to do is going to talk through these and explain a bit about them. So when you see these concepts coming out, you know, and you're looking around the web at the different technologies, it's not just like, what does that mean? Because that's when I started. When I started to look into these tools, I was like, there's so much in terms of new lingo, new technology to understand. And I just want to sort of demystify it, make it less scary, you know, that's how I know. That's probably a live photo of my face when I started looking at this, like, what? Yeah, so don't panic. And we'll look at the why and when you want to use these tools as well. Cool. So I'm going to start with static site generators. These are like your most basic form. They're quite popular. You know, GitHub uses Jekyll. And these are the simple ones. And they're really good for static content, like a blog post or something like that, where you really just want to generate through HTML. You're using simple templates. Nothing's very dynamic, but it's fast. That's the key thing. You know, if you want to generate tens of thousands of pages in a short order, then static site generators are going to be brilliant for that. You can obviously upgrade these things with a bit of JavaScript if you want to use things like jQuery, but it's going to be very, very, very simple. And as you can see there, so generated on the server, delivered as HTML. No. And the nice thing about these as well is once you generate them, they're just flat HTML files. You can drop them on any web server. That just serves files. You don't need any fancy infrastructure running in the background. So this is like your first starter for 10 if you're coming to this new world. We then move into single page applications. This is where like this whole shift to JavaScript really sort of kicks off, I think, was when people were like, well, what about if we just get the browser to do almost everything for us? You know, what would that experience be like? How can we make our websites much more interactive, much more like a mobile phone app or something like that? You also have to think that this also kind of starts to break the barrier between mobile phone development, where you're using native languages and web development. There's tools that came out that allowed us to make a website using standard HTML and JavaScript, put it in some fancy wrapper, and then actually just install that as an app on a mobile device. And that was all powered through JavaScript and these sorts of tooling on the front end. Spas are great for certain usages because they give you this level of interactivity, this level of click a button, everything changes pretty quickly. You're going to be using REST APIs and things like that to grab data. But in terms of responsiveness, they're very responsive for that app experience. Where they don't tend to work is when we're doing brochureware websites. You know, if we're doing like typical marketing websites, like a lot of our Sitecore clients, this isn't a great solution because you've got a huge payload to download. You've got to download all that JavaScript. Now, the frameworks are doing really great work in trying to split up and bundle that JavaScript so the payload is smaller. But do you really need to load up a full JavaScript application if what you're doing is rendering an image and a call to action? You know, it seems a bit overhead. And if you then think about, you know, your lower performance customer, somebody who's got an older mobile device, you know, they may find that experience is pretty awful because their device just can't cope with the amount of JavaScript that's having to run within that browser. So these tools are really good, as I say, for creating an app experience, but you probably don't want something for your brochureware site. And as we'll see in a minute when I talk about hydration and the uncanny valley, we'll come to that term in a minute, they are also not great for time to first load and also problems with SEO as well. Like any React application has always struggled with how do I get myself indexed by Google? So then we come to SSRs. Now, SSRs, or server-side renderings, they were trying to tackle this gap that SPAs created, which was, how do I get my pages to be SEO-friendly, and also how do I get that time to first view down? You know, how do I get it so that the information there is instantly available to the user when they click on my website? You've probably all seen the Google stats where something like 0.1 second delay, I think it's somebody yesterday, 0.1 second delay can make a difference between about an 8% conversion. Well, the problem with SPAs, if you're running your site on a SPA, is you've probably got a 4, 5, maybe up to 10-second delay before the user even sees anything. And then it may still be layout shifting and things like that as the page loads because it's still pulling in more data. JavaScript is still trying to run. So SSRs were kind of trying to trick this process. So what they would do is they'll render the HTML on the server. They will then send that HTML and also serialize the state of the page, send it to the front-end client, and then you will saw the HTML page initially, but then behind the scenes, it's creating the whole JavaScript application in the background. Now, that JavaScript application looks the same as the HTML once it's loaded, so you don't see the change where you go from plain HTML to a JavaScript application. So you as a user think you've had this instant response, but actually it's just a sort of trick of the system that they've designed. And so yeah, this is where NextJs comes in. You know, Next has done an amazing job with building React out in that way. Blazor, again, very much sits in this SSR space. I'll just go on to the next slide. Like I say, now that Blazor came along, we are all now full stack developers. So if you want to go and update your LinkedIn profiles, you know, if you know C#, you can now program JavaScript. But SSR doesn't come without its own problems. You know, and we'll look at that in a second as well. SSR isn't the golden bullet that people hoped it would be, I think, in terms of performance and content delivery. And so there are other frameworks now that are hoping to come in and tackle some of those challenges. Cool. So this is what I want to talk about, hydration. Now, a lot of SSRs use hydration as their method of reloading applications. And this is why I said, if you use web forms from back in the day, it's kind of like a similar thing, whereas web forms would do hydration on the server. So in classic ASPX, you would render your page. Web forms would then create view state. And if anyone remembers view state, it was this massive bunch of gobbledygook that was hidden in your HTML. But when that went back to the server would read that gobbledygook, reconstruct the page, and then layer over any changes that need to be made on top of it. And you'd get this kind of almost desktop-like feeling to the interactions, but from a web page. So that was really about allowing desktop developers to create web pages in many ways. Hydration in this environment is kind of a similar thing, but what we're trying to do is hydrate the client. So you know I talked about that JavaScript application that gets booted up once you see the HTML? Well, it needs data, and that data comes from hydration. So what you often see is you look at like a NextJs site or something like that. If you look at the view source, you're going to see the HTML. And that's the thing that you're immediately seeing. But at the bottom of the page, you're going to see a massive payload of JSON. And this is all the serialized data that was generated on the server that it needs now to send to the client so that it can rebuild this React application that's now running on top of the page. You can see here it's good because while it's hydrating, the page is visible. But the problem we end up with is a page usability problem. So the user can see the page, but it may not be usable because that application is still trying to hydrate itself, still trying to rebuild itself. Other challenges we see as well with hydration is that if you're not explicit about what data you want to send to the browser, you can end up sending all sorts of information. You know, because it's just encoding your JavaScript object. If you don't strip that down, you could end up just pumping out everything into the page, things that you might want to hide, things that might be sensitive. So hydration is good, but you need to think about what data you're sharing and minimize it as well. We also have this thing called the uncanny valley. Now, what this refers to is, as I say, this time between the largest content paint, and the first input delay. So the page is visible at this point, the page is usable at this point, and the user is sat there going, well, why can't I respond? Why won't this site do anything for me? You know? And this is particularly a big problem on slow devices. So you can see just click, 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 click. Doesn't want to do anything. So other frameworks are coming along to try and improve this, to try and make this more performant. So we have things called progressive hydration. So frameworks that introduce progressive hydration will basically start at the top and work their way down. And you can do some sort of markup to say, when should this be hydrated? So rather than get everything rebuilt as soon as the page is loaded, we could say, right, only hydrate this section when it actually gets scrolled into view. And then only do this section when it scrolls down again. So all the time, we're trying to minimize the actual overhead of rendering these pages. So if you see partial progressive hydration, this is what you're going to be sort of looking at. And you can put in trigger points. Certain ones will also allow you to sort of do the hydration when the user isn't even using the browser, so you can just sort of sneak in the background and do some things in the background. The next approach to solving this hydration problem is called island architecture. This makes, I think, quite the sensible assumption that probably, like, when we look at this, like 90% of this page is not interactive. It's just text. It's just images, a bit of content, probably a link. But what we can do is we can identify the areas where we want our interactivity to be. And what we do is we just hydrate those areas. This makes it a much quicker system. You know, it's almost like just working with flat HTML and then just a few bits of data to make things interactive. These tools, I think they're really clever. Don't know how they work on the back end. I mean, it must be so complicated to actually build this, because when you look at how they do it, they make it really simple for a developer. And then in the background, during the compile time, they're doing some really smart stuff to strip out the bits that they know you're going to need, the bits you don't need. You don't need. So they're doing some really complicated computation on the compile, but it works really well. So we're looking at tools like Next does it-ish at the moment. I think this is still early stages for Next in this area. I think probably the best player in this is AstroBuild at the moment. There's a lot of talk about that. Astro is actually quite clever because it actually sits on top of other frameworks like React. So if you're coming from a React environment and you want to use island architecture, you can just sort of plug that straight into Astro. I haven't done an experiment to see how easy it is to take an existing Next app and move it to Astro, but I think that should be possible. Or at least if you've got a componentized architecture, moving across if you needed to would be quick enough. I think Astro, though, is still in the early stages of doing SSR, though, so you may still have some first load issues, but yeah, it's a good tool. Other people have decided to take a completely different approach, and you'll see frameworks now coming out that use the term resumability. Again, they are trying to get across past this uncanny valley scenario. But in this scenario, what they do is they generate the page on the server side. Something clever happens in the build process, and they kind of like pause the page at that point in time. Send that page to the browser, and then it's almost like somebody's unpausing and it plays again. That's how they describe it. I'm going to be honest, I'm not sure how they achieve that and how it differs really from the hydration. But the idea here being that rather than hydrating a whole component tree, you're just pausing it at that point in HTML in time. It will then probably make a callback to the server to load the data it needs when you click the button. So they've got some handlers and triggers that then make fetch requests. The idea being this is very quick and very lightweight, because you're only, again, requesting data in JavaScript at the point when the user actually needs it. Whereas something like the traditional hydration process that Next goes through tends to load all the data up front, even if the user isn't going to do it. You know, if you're using something like Next, you may have a very complicated JavaScript component that the user has no intention of interacting with, but it will still send it to the browser. It will still be required to be downloaded by that user. Then we come to what is sort of the new in the marketing space. I think it's just a new name, really, edge rendering. Traditionally, I would say it was called serverless. They kind of occupy the same space. Edge rendering is this idea of having serverless functions that will generate you HTML and allows you to do a level of personalization, authentication, interaction, and stuff before the page is sent down. You have to remember things like SSR and SSG and stuff like that. They're not so much focused on personalization. You really don't want your SSR page regenerating for every user that comes to that site, because otherwise you're not taking advantage of the caching mechanisms built into those tools. So to get around that sort of problem, edge functions are introduced to actually allow you to go and do that personalization on the fly as it's needed. So again, we've got Azure serverless functions, have been around for ages. Got AWS Lambda, and now Next is coming in with its edge functions. The Probably the advantage of using Next, though, is that they're kind of always on hot standby with their edge functions. I haven't used Lambda, but I know with like Azure and stuff, if like you're not using your functions regularly, they'll tend to sort of go into like a sleep mode, and then there's a delay when it's kind of booting up and having to warm up again. So if you really want fast, rapid response, then Next Edge functions are probably the best thing. But if you've got a bit more time and you want to write in a language that you're more comfortable with, then serverless functions, in C# will do as well. Cool. So those are sort of the new terms and technology that you're going to be seeing. And next, I want to go through some tips and tools that I've been using within my day-to-day sort of React development, front-end development. These are the kind of things that I wish I knew when I started, or the tools I wish I knew when I had started, because it would have saved me a lot of effort, made my development process a lot easier. Who's heard of Storybook? Awesome. Very popular now. It's it's probably my favorite tool in terms of like front-end development, because it really allows you to focus on componentizing the UI and also forces you to separate your concerns. In Storybook, you can only focus on the front-end logic. You can do a nice atomic design setup, so you've got your molecules, your atoms, your organisms. So it forces you to structure in a nice way and then separate that code from the back-end code. It's also really nice to show a client, because they don't expect to see this kind of tool where you can go in and go, well, let's just put a long title in and see how it breaks. Let's just change some colors really rapidly and just see what it looks like. It's a great sort of prototyping tool as well to give clients. So if you haven't checked out Storybook, really recommend check it out. And that should be like your starting point with your UI team, I think. It allows you to also create like a design library as well, put all your design rules in, put all your color rules, border rules, all that sort of stuff can go into this tool. So not only does it become the place where all your components are, but also becomes like a self-documenting environment. And the Storybook team are really, really active in building this out. I'm going to come back to hydration, and this is the hidden payload. I wanted to come back to this because you can see up here, we've got a bit of HTML, and then the JSON wall of doom. And I think this is important because view state in web forms days used to be like most of the page. It was crazy. And as you can see there, here it's still quite a large payload. It's like 31% of the download. And this is where you need to really think about. This wasn't even a complicated page. This is like the Conaboss homepage. It's not a big page. It's got some text, some logos on it, a few CTAs. But somehow we ended up with quite a lot of additional data. And the challenge is, especially with something like Next at the moment, is you can't strip that out. It puts it in there automatically for you. So it's a bit frustrating. Cool. Another challenge for me as a .NET developer who's used to a server architecture is the page building in isolation. So we're used to being able to cache data on a server. If we're building for one page, we could probably cache some of that data and then use it again on another page. Or if you're using Sitecore, you just check the cache variants and it will store it for you, so you're not having to constantly rebuild this. We also have things like session state and stuff like that. When you come to things like SSR and SSG, you don't have those mechanisms. Quite often they're doing a single page build and it's completely rendered in isolation. What that means is when you make your request for page one, you've got some data from one service, you've got data from a database, you've got something from another service, you built your page, then you need to do page two. Well, this is built in complete isolation, so all the work you've done over here is forgotten. So when you do page two, you have to make all those requests again. This creates several challenges when you're integrating with back-end systems. One, API request limits. With some service providers, we hit these limits quite quickly. Especially you're generating maybe like 10, 20,000 pages on the fly. You're going to hit those requests, especially per second limits as well, where maybe, I think XM Cloud is 81 requests per second, think that's something like that, isn't it? About 80 requests per second. Well, you know, on a build, if you're building 10,000 pages, you can easily hit that. This meant that we actually had to put a caching layer in front of, not with Sitecore, but with another provider. We had to put a caching layer in front that allowed us to grab the data, cache the data, especially for these common header components, like that sort of stuff, and then build off the cache that allowed us to have a higher API throughput. You're going to need to limit your business logic probably in this environment. Again, because you're really wanting to generate a single page that is static and can be reused. You're going to want to limit your business logic in the page itself and think about moving that off to somewhere else like an API. It's a sort of different architectural thinking, or putting some of that business logic into the actual client-side code itself. Another one is no session. So if you're used to using session state when the user comes to your site and maintaining data about the user via that session, you're going to need to think about a different model. And that brings in things like security considerations. Like if you keep that session data maybe in local storage for the user in the client browser, what happens if they try and modify it? You know, does that create a security vulnerability? So how do you secure that? Do you need to then have some sort of checksumming on the data there or something like that? Or do you need to build it out somewhere else and maybe have a redis cache somewhere and you have a mechanism for reading against the redis cache or something like that? So I say here, APIs were also a challenge for us. Again, because you have this kind of mixed access model. If you're doing server-side generation, you need to potentially access an API from the servers as the page is loading. So you've got that first load data. But then once the user has loaded the application in the browser, they also will need to potentially access that API from the browser, from the front end as well. So if we take an example of maybe like the SUGCON events page, okay, you may want to get all the events and list them in the HTML. So when somebody goes to the agenda, they see all the events in one go when it first loads. But then they click on an agenda item, and you just want to show a pop-up of that specific event. Well, you may need to go back to the API to get a bit more data. So the first page load was rendered on the server, but the second piece of information they see is actually going to be made via a request from the browser to your API. So if you need that API to be authenticated, how are you going to manage that? You know, do you have machine-to-machine tokens so that you can do it just on the server side and then have the user authenticate separately and then manage two sets of access permissions for the user? It can get a bit complicated. Do you try and build a proxying service using edge functions so that you only have one M2M machine-to-machine key and all requests from the websites get proxied through that proxying service? That's a simpler solution because you don't have to manage multiple authentications, but then how do you protect the proxy if the data needs to be secured? So then you have to think about these architectures a little bit more. It becomes a little bit more complicated. Other things to consider are making sure that if you are building out these APIs, that you follow best practice. You know, really make sure that you follow REST protocols, because that just makes everyone's life easier. Don't go off trying to reinvent the wheel. Make sure it's REST. There's a good talk yesterday about if your REST service throws an error, return a 500. Don't return a 200 with an error message or something like that. You know, the good thing about this is actually one of the good things about this environment is that we actually have to start learning the HTTP protocol again. You know, we have to understand the difference between a 401, a 301, 302s, all those sorts of status codes. So that's kind of good. Swagger is brilliant. If you're working in a .NET space, you don't even have to do anything. You just install the extension that somebody's written, and it will create your Swagger documentation for you. Another good discussion is around Azure Function and web apps, I think. These are where we're Azure. We're all Azure where we are, so we're not too much on AWS. But if you're building out APIs, you want to think about when to use Azure Functions versus Azure Web Apps. There are limitations on Azure Functions like middleware and things like that. So if you want middleware in your endpoints, then you may want to use something like Azure Web Apps. And then you might also want to look at service meshing on top of that to manage security, load balancing, request limiting and things like that as well, just to protect any API that you are building out. Finally, my last slide before conclusion. One thing I think is really interesting with this move, though, is that we have to think beyond the Sitecore architecture. Traditional sort of XM development allowed us to kind of use Sitecore to be the one thing that ruled them all in some ways. You know, we would design our pages and our renderings, build that into our presentation layer, and then if we needed an API, we could actually still do it in Sitecore. You know, we had the /API/Sitecore endpoint. We would just create another controller. We'd probably use Newtonsoft to convert that data, send it back, job done. Probably a bit of jQuery just to read it. And Sitecore becomes the one thing that does everything. With this new architecture, it can't be that. You know, you are going to have to think about, right, we've got XM Cloud sitting over there. I've got my next Vercel instance running over there, loading data. I'm probably going to have something like Auth0 sitting over there for authentication. You know, suddenly we're bringing in a bunch of different services. We may be having, you know, Azure functions sitting in another place. So you have to start really building out and thinking more strategically about the architecture, where things will sit. Request times, you know, we're building everything now through APIs that make HTTP requests. There's going to be a latency in all those requests. You know, how does that affect your page? It's a much more considered environment to work in. So architecting is much more complicated, I think, but it's much more interesting, in my opinion. Like, it really opens you up to being able to explore more tools. And then one thing that Sitecore likes to, well, one thing every developer likes to do is to play with a new tool, isn't it? So if we can all get new tools, it's great. Cool. So in conclusion, now we're seeing that the old traditional days of everything on one box, that is going. We are going to be breaking it down. The Sitecore, I think, is really doing a really nice job in actually breaking its services down so that you can bring these services in as you need them. Okay. That's also, I think, a really key thing to talk with your clients about, is like, they just need to maybe start with like something like XM Cloud or Content Hub 1. And then once you've got this part built out, it's really easy to start bringing these other tools in as you need them. And the architecture we've been building on now, this kind of composable, really supports that. The hard part for you is going to be deciding which one of these you want to play with, which ones you want to start with. I would recommend, like, if you've not done anything before, start with Next, because it's probably the easiest one to start with and understand. And there's really good tooling and support for it. Cool. So yeah, change is inevitable, but growth is optional. I like this quote because I just thought, you know, we can either embrace this, or you can try and fight against it, but I don't think that's really a growth strategy for any company. You know, the world is moving forward. We have to embrace the change. Cool. Any questions? A bit early. Cricket. Hey.
I saw you mention Blazor.
Yes.
SSR paradigm.
Yeah.
How do you think WebAssembly and Blazor are going? Do you think that there's a big future for Blazor, or do you think the adoption's not been as it might have been thought a few years ago?
I worry in the sense that we sometimes see these initiatives like Blazor get picked up and then not executed or dropped when support isn't shown. And so it becomes a chicken egg, because you may want to adopt it to show support, but then if you adopt it but no one else does, then you invested in this thing that's now getting stranded. It's interesting. I worry with WebAssembly, are you going to get enough of the front-end developers moving across? You know, because there's a large investment now, especially with large companies, in having JavaScript, TypeScript developers, and they can move between the different TypeScript frameworks, different frameworks that use TypeScript quite easily, like Vue, React, and that sort of thing. How much effort and how much work would it take to retrain teams into something like WebAssembly? It's a stricter environment. It's a more complicated environment. Will companies make that transition? I think there's definitely space for it. I mean, it's going to be quicker. You're going to get a lot more advantages out of performance optimization. So maybe it will make sense for companies who are more focused on developing web apps for the browser, where performance, or you're developing browser-based games and stuff like that, where performance is key. But I think this build probably for more brochureware, for more e-commerce sites, we're probably going to see people sticking more with the sort of JavaScript and TypeScript world than trying to move to a WebAssembly setup.
Cool, agree. Thank you.
Great presentation. You mentioned about architecture beyond Sitecore.
Yeah.
And what would you think is the first step someone should take to be able to, be able to look at that overall picture as a developer? So
the first step, if you've got an existing implementation, the first thing is just to identify what you're actually using within that existing implementation. I suppose it's a Sitecore event, but I'll still say this. There's always that old adage that people have bought XP, but when they actually look at what they're using on Sitecore XP, they may not be using personalization. They may not be using the XConnect parts of it. So you really want to do an assessment of what is your current real estate, and then start to think about where do we move the different components of that. Where is our business logic at the moment? Is it hidden in MVC controllers? Probably. Is it properly separated from them? Possibly not. So right. So now we're going to need to separate that out and find somewhere to host the APIs for that. Then you're going to have to think about where we're going to put our content. Is it going to be XM Cloud, or is it going to be somewhere else? How do we do personalization? Which services do you want? So you need to think about how you're going to separate these things out and then bring them back together again.
Great presentation. Did you look at React server components yet in Next 13?
No, I haven't had a chance to look at that one yet.
Well, they promise anyway that then all the hydration issues are solved. So
all right.
I'll be curious to see if that will make a difference.
It'd be interesting. I mean, I wonder if they've solved it in a similar way, because if you look at something like AstroBuild, the way AstroBuild does it is you mark up your React components and you say this is a server-side one and this is a client-side one. And I wonder if maybe Next 13 is doing a similar thing, so it knows which ones to send.
They're doing like a funny thing that they invented a new protocol, so they're not sending JSON anymore. They actually send React code over the server.
Okay.
And then you don't have to hydrate anymore. That's the whole...
That's interesting, because one of the things, especially with hydration, is that at the moment the data has to be serializable. And one of the issues you get is if your data is not serializable, you will get an exception. So it'd be interesting to see how, if they are sending React code from the server through a hydration process, how they're serializing that. Cool.
Yeah, hi. I have this question. In the process of migrating from a legacy Sitecore MVC solution to a headless JavaScript-based Next, for example, of course, there's a big task of like re-engineering your front end from being plain old MVC to JavaScript-based. But what about the content? Is there any roadmap or migration path? Because I suppose that the content itself, the structure in your content tree will be different to cater for the differences in the front end.
I'm not sure if it does actually, the content structure actually changes that much, because if you've got a good site IA already, then the content kind of stays in the same setup. If you've got a blog content item within Sitecore XM, when you go to XM Cloud, you're probably still going to have the same kind of blog item. You can almost bring that data across as is. Things that will change is you may not have data sources. Personalization content may need to go and live somewhere else and be brought together in a slightly different way. But most of the fundamentals, I think, will still stay the same in that migration.
Yeah, I was more thinking about data sources like you mentioned, but also layout details on the items, which I suppose will change in this case.
Yes, yeah. Layout's going to be a different challenge, because you've got to compose that in the front end now. So I haven't done that specifically with Sitecore, but we did manage to make a sort of component layout with another provider. They didn't actually have a way of composing the layouts. We actually kind of built that into their content management system. And so you can still definitely do that, but it becomes more complicated when you're doing the server-side rendering. Again, because of that kind of individual component build, we have to make a request to get the layout, and then for each component we then have to make a different request to get the data. And so then suddenly we're really hitting quite high API limits, because if you think about maybe a more normal Next app that isn't using something like Sitecore, it just loads the data it needs for that specific page, and it can probably get all that data in one page because they're like, we're a blog, and we're just going to get the header, the footer, and the blog in one go. But when we're doing layouts in Sitecore, we like to give the content editor the ability to say, I want to use this CTA, and I want to pull in this other image from here, and I'm going to create a data source item over here for something. And then you can't just get all that data in one go. You have to query the page and then access each of those parts individually, and that's where your API limits are coming in. So you may need to think about like how flexible do we be on this component architecture? How many components do we allow a content editor to put in? Because we now have technical limitations through the request limits. Cool.
Any other questions?
No? Cool. Well, thank you all for coming. My name is Mike Edwards.